This is Mr. Lovell with Math Adds Up. Today we're going to talk about proportions, what they are, and why they're important, how we use them. Before we can talk about proportions, we need to make sure we understand what ratios are. Ratios are simply a comparison of two things that we can give a numerical value to. And we write ratios three different ways. We either use a colon, as in 4:1, we use the word to, or we write the ratio as a fraction. For most of what we're doing in math class, we'll be using the fraction form of ratios. Here we have some red squares and some green diamonds. And our question is, what's the ratio of squares to diamonds? Well, this is simply a counting process. And when we count, we find that we have 15 red squares and we have 20 green diamonds. So we would say that our ratio of squares to diamonds is 15 to 20. And order is important here. If we're talking about squares to diamonds, then we need to make sure that squares is our numerator, or the first number, 15 to 20. Now, since we're writing this ratio as a fraction, we can do all kinds of fraction-like things to it. In particular, we could simplify this. 15 to 20 is the same as 3 to 4. And by doing that, I've just created a proportion. A proportion is just a fancy way of saying that two ratios are equal. So 15 over 20, 15 to 20, is a proportion with 3 to 4. Two ratios that mean exactly the same thing. We can prove that two ratios form a proportion by using cross products. When I do cross products, it means exactly what it says. I take my numbers that are across from each other on that diagonal and multiply them together. 5 times 9 is 45. 15 times 3 is 45. If I get the same number on those cross products, then I know that these are a proportion. Those two ratios are equal. Those two ratios mean the exact same thing. We can use cross products and what we already know about solving equations in order to find the missing number in a proportion. I have two ratios, 4 to 6 and 9 to some number, that I know are a proportion because there's an equal sign between the two ratios. I'm going to use cross products because I know that 4 times n has to equal 6 times 9, which is 54. Well, this looks a lot like some of the one-step equations that we've been solving. And how do we solve a one-step equation? Well, we isolate the variable by doing the opposite operation with the exact same number. So I'm going to divide that side by 4. What I do to one side of my equation, I have to do to the other side. Remember, this is going to go away. 4 divided by 4 is 1, so I have 1n on the left-hand side. And 54 divided by 4 is equal to 13.5. So n has to be 13.5. I found the missing number in my proportion. Let's see how this helps us solve a real-life problem. I want to figure out the height of a tree. I know that that tree is creating a shadow that is 28 feet long. So I have a tree of some particular height, let's call it n, creates a shadow that is 28 feet. Well, The person that's standing there is going to create a shadow that is proportional to the tree's shadow because they're standing under the exact same sun. So I know that a 5-foot person creates a shadow that is 8 feet long. Now I have my proportion. The height of the tree to a 28-foot shadow has to be equal to the height of the person, creating an 8-foot shadow. I'm going to go ahead and use my cross products at this point, and I find that 8 times n has to equal 5 times 28, which is 140. Again, I'm going to isolate my variable by dividing both sides by 8. I now have 1n on this side, and that n is equal to 140 divided by 8, which is 17.5. That tree is height of 17.5 feet. Now there is one very important point that needs to be made here in setting up your proportions. Notice that I have everything in the same place. I have the height of the tree in the numerator position on my first proportion, my first ratio. I have the height of the person in the numerator position of the second ratio. So I have height to shadow and height to shadow. I have to have the same thing in the same place in order for this to work. Let's take a look at another example. I have a 6-foot person who is creating a 5-foot shadow. I have a flagpole of unknown height, and it's creating a 27-foot shadow. My cross products will give me 5 times n has to equal 6 times 27, which is 162. Solving my equation by dividing 5 for both sides gives me 1n is going to be equal to 162 divided by 5. And that results in a flagpole height of 32.4 feet. 32.4 feet. Now let's just do one last thing. We have our original height to shadow of 6 to 5, 6 feet to 5 feet, and we're now saying that that is equal to 32.4 feet to 27 feet. We can prove that this is correct by coming back and doing our cross products here, and we find that 6 times 27 is 162, and 5 times 32.4 gives me 162. We know that we have done this correctly because we have a resulting proportion where the cross products are equal. I hope this has been helpful. This has been Mr. Lovell with Math Adds Up.